All right, so we've been practicing writing expressions, so taking a look at a word problem and turning it into, finding a pattern and turning it into an algebraic expression. And so what we're going to do is we're going to talk about how to evaluate that expression, so then to put that pattern that we saw to use. And to do that, first we obviously have to write the expression, and then we're going to plug in a value for each variable. And once we do that, we are going to simplify the expression that we then have, that's all numbers, and find out what that equals. So down here, for instance, they've written for some situation, we've written an expression, and they want to know when x is -2 and y is 5, what does that expression equal? So when I rewrite it, I'm going to take the original expression that I have here, and I'm going to plug in anytime there's an x, I'm going to plug in a -2, and then I'm going to plug in a 5 anytime there is a y. So I end up with 3 times -2 plus 4 plus 5. And then to evaluate that, or simplify that, I am going to then actually solve it. So I would look at this and I would say 3 times -2, well that's -6, plus 4, plus 5. So I can either add, this is all adding, so I can do this in any order. So I could say 9 minus 6 is 3. I could say -6 plus 4 is -2, and -2 plus 5 is 3. But my answer is going to be 3. So we can see that sequence of steps there to find that. All right, our next one over here, we don't have two variables, we just have one, we just have the a. So I want you to pause it and see if you're like, okay, I got this. If not, go ahead and keep watching. We've got -4 times a plus 3 times a plus 1. So I want to find whenever a equals -2, what will that expression equal? So the -4 and the 3 and the 1 all stay the same. And I'm going to put my -2 in wherever there was an a. So -4 times -2 is +8. 3 times -2 is -6 plus 1. Now we know that adding a negative is the same thing as subtracting. So this is 8 minus 6 plus 1, which is 2 plus 1, which is 3. So our answer happens to be 3 again. Every time you evaluate an expression, the answer is not 3, I promise. Alrighty. Our next one has 3 variables, and it also has an exponent. We're going to be squaring. So I've got 2a squared plus 3b plus c. So this is my original expression here. And wherever there's an a, I'm going to plug in a -3. Wherever there's a b, I'm going to plug in a +4. And wherever there's a c, I'm going to put in a 5. So what's staying the same? I have 2. And then I'm going to be squaring whatever I'm putting in there, plus the 3. And now I'm going to go plug those in. So I need an a, so I'm going to put the -3 in there. Notice I put the parentheses around that. For the b, I'm going to put in a 4. And then for the c, I'm going to put in a 5. When I go to simplify this, I need to know that I need to square this first. And because it's in parentheses, I'm going to actually do -3 times -3. Well, -3 times -3 is 9. So now I have 2 times 9 plus 3 times 4 plus 5. So 2 times 9 is 18. 3 times 4 is 12. And then plus 5. 18 plus 12 is 30. So we get a final answer of 35 in this case. For this last one, we'll be talking about eventually here the distributive property. And I could distribute this out, and I'm going to try to show it to you both ways. So if I have 6 times the quantity x minus 2, and so I want to substitute in a negative 1 there. So I'm going to have 6 times negative 1 minus 2 there. Now I could go ahead and do what's inside the parentheses first. So then I would have 6 times negative 3, which equals negative 18. I could have also gone 6 times negative 1 plus 6 times negative 2, and I would have gotten the same thing. I would have had negative 6 plus negative 12. Down here it says, what is the value of this expression? Oh my gosh, we have a fraction. It's okay. Every fraction is a division problem. So it wants me to substitute this 12 in where I see n's, and there's 2 places. And wherever I have a p, I'm going to substitute in my negative 2. So now I have 12 over 3 minus 1 plus 5 times negative 2 minus 2 times 12 minus a negative 2. So this is the toughest one we're going to see here. So my next move here I'm going to go down so you can see a little better. 12 divided by 3 is 4 minus 1 plus 5 times negative 2 is negative 10. Minus 2 times 12, which is 24, minus a negative 2 here, so that's where I'm going to go plus plus and get plus 4. Now it's all addition and subtraction, so I'm going to go from left to right. So 4 minus 1 is 3. So plus negative 10 minus 24 plus 4. 3 plus negative 10 is going to give me negative 7 minus 24 plus 4. Remember, you can think of this as adding a negative. That's going to give me a negative 31 plus 4, which is going to give me a negative 27. At the bottom here, you're going to be writing the expressions and then evaluating them. So to get into the county fair, Patricia must pay a $5 entrance fee and $2 for each ride. So the each means I'm going to see some multiplication. And more means I need to use some addition. So it says I'm going to pay a $5 entry fee and $2 for each ride. So each ride, that's going to be my variable. So I'm going to use R for the number of rides. And it's $2 per each ride. And I also have to pay a $5 entrance fee. So there's my expression. Now it says, what if Patricia rides 10 rides? So I'm going to do 2 times 10 for the 10 rides, plus 5, and find out that Patricia will spend $25. On this next one, less means I'm going to subtract something or have something that's negative, and split evenly means I'm going to divide. So it says Elaine and her friends went out to dinner and decided to split the bill evenly. So they are splitting the bill. So whatever the bill is, the cost of the dinner was $56.75. If there were n people, number of people out to dinner, so we know that n is the number of people, how much did each person pay? So I need to split my bill evenly here by the number of people. So I'm going to do $56.75, and I'm splitting it between so many people. And I said, what if there were 8 people out? So it's $56.75, and now I'm going to divide by 8. And when I do, I don't know, there's a little glare there. When I do $56.75 divided by 8, I get $7 and 0.09375. Wow, so I'm going to stop at the $7.09, and that 3 tells me to keep it the same. So everybody's going to pay about $7.09, but that might leave us a little short. We might need to make it $7.10. I want you to think about which way you should go there. All right, so our next example says the landscaper charges $30 for each job plus an additional $20 for each hour. So we have each job and each hour. Write an expression to represent the total cost of a landscape job. Explain what the variable used in the expression represents. Well, we could actually have two variables here because I could have $30 times each job, or 30J. So J could equal the number of jobs that I do, because maybe I do more than one job in a day. I don't know. Not a landscaper. And H could be the number of hours that it took me to do that job or jobs. So I could have plus 20 times H. So it would be plus 20H. So I could have two different variables going on. So let's explain how you identified the operation using the expression. Well, because we were doing each, that's going to be our multiplication. And additional. All right, and additional means I'm going to add. So it says if the landscaper worked 40 hours per week, how much does he receive on his 2-week paycheck? So they've gotten a couple things in here. It's 40 hours per week, but we're doing this for 2 weeks. So there's 40 hours for the first week, but there's also going to be 40 hours for the second week. So we have a total of 80 hours that we're evaluating this for. Now they don't tell us how many jobs that he did. So you can look at this two different ways. I could say maybe it's all the same job and put 1 in. And then I'm going to have 20 times my 80. And there I get 2 times 8. And then I have in the 2 zeros. So 2 times 8 is 16, the 2 zeros. So then I would be making $1,630 for the 2 weeks. If they are thinking, oh, because we didn't tell you how many jobs you would take the 30 out, then it would be just the $1,600 that he's making for the 2 weeks. I would read that if I was taking the test as there's one job going on, and I would add in that $30. Our examples down here, they want us to write these out in words. So 3x minus 5, I would say 3 times... And you're like, oh, wait a minute, but the minus 5 is at the end. So we don't want to start out with that. We want to say 5 less than 3 times a number. When I substitute in, I'm going to be substituting in a negative 2. So 3 times negative 2 minus 5 equals negative 6 minus 5, which you can think of as adding a negative 5, and we get negative 11. This next one, I would say 6 times. All right, we're going to say 6 times that we're adding. So 6 times the sum of a number and 7. I'm going to evaluate it for 3, so I have 6 times 3 plus 7. Remember, I could do 6 times 3 plus 6 times 7, or I could do 3 plus 7 is 10 times 6, and I will still get 60. So we could say this one is a number divided by negative 10. So when we substitute that in, we'll get negative 50 over negative 10, and we get positive 5. Remember, if at any time you need to, stop, slow this down, or go back and re-listen to it. Next one says, write a word problem for the following expression. 2 times a number plus 4. So I might say if I go to Kings Island, for instance, and it's dollar days, and it's $2 for each game, and then it was $4 for the little cards that you get that you load up if you've ever been to Kings Island. So $4 for my little card that loads up. So I might say, during dollar days at Kings Island, I'm going to pause this and keep writing it. All right, so you're going to want to pause and look at that. And I want you to try to come up with an example of your own. I was running out of my time there. So if I plug that in and I played 4 games, it would cost me $12. Once again, pause whatever you need to do and be ready to come in and discuss and use this information tomorrow.